Welcome to Defan, and luckily this is not a live show, so you don't know that we are horribly delayed because of me. This is episode number 82, I think.
It says 82 up there.
It says 82 up there because I typed it, so I
Okay,
don't
okay.
know if I typed it right. It's like one of those Wikipedia articles. You just go and then edit it yourself and then claim that that is the truth. So yeah, let's settle on 82. So this is episode number 82, and this Vijay, as usual, a bit late to the to the recording, and we have Ray. Ray, are you still in Belgium, or
Still
does
in
it look like
Belgium.
you're? Okay.
There's no news of me moving unless you know something I don't.
So you got boosted as well.
I got boosted. Yeah.
Oh, nice. Yeah, me too. Yeah.
You've been transposed to another location, undisclosed.
Yes. Especially for a deaf recording. Anyway, hey, wait, who's the mystery noise?
That? Yeah, whoa.
Yeah, God.
Yes, hello.
Announce
I am
yourself.
Ben. My name is Ben Sless. I love closure.
Well, that's it. You did everything you're asked to do, and then you can take your money, and then that's it. That's the podcast.
Yeah.
Everybody coming here.
I fell backwards into closure, and best happy accident, I have to say.
Nice. Welcome, Ben. Welcome to the episode.
Thank you. You.
So which undisclosed location are you based in?
I am in the undisclosed location of Israel.
Ooh.
Yes.
Right.
And currently located in the small-ish city of Herzliya, right outside Tel Aviv. And that's where I live. That's where I work.
Ooh. There is plenty of Israelites or in closure community now, right?
It's relatively.
Yeah.
Not
because
as,
of the Texan.
As a proportion,
really
there seems to be a lot more Israelis than Indians.
That's true. But
the relative size
in
of
closure,
the population.
you mean in closure, not in.
Yeah.
So it's usually a function of like the company that is the hub for that. If you look at the Google Trends, for example, you'll see that most Google searches for closure are centered around Herzliya. Just like in Finland, you'll see that most closure Google searches are centered around Tampere.
Right.
Well, that would mean people in those cities are getting stuck with closure a lot. There are zero closure queries from where I live from, because that means everybody is expert at closure. They don't need to Google for this shit anymore.
Yeah, they don't need help. They know their shit.
Yeah, totally.
Also,
yeah.
most closure programmers are using DuckDuckGo now, so it's off the list.
Yeah, that's true. Yeah. Anywho, somewhere near Tel Aviv. I'm not sure if I can pronounce your town's name properly.
It's okay. It's almost as hard to pronounce as my surname. Well, yeah, but you're from England, I presume, so for you it's quite easy to pronounce. But that, or like the origin from which it was simplified, which was Schlesinger, which is even harder to pronounce, especially when you just see it written down. So around 3 generations ago, it was changed because it was hard to pronounce and to read.
It's like, okay, these people can't spell our names, so I'm going to make it easier for them.
Well, I think you Indian folk have a common problem there.
We don't have the problem, because good evening, my name is Michael. How can I help you? We're all named Michael from tech support anyway, so that's much easier.
Yeah, and then you try to read the Mahabharata, and it's like it takes a couple of minutes to get through the title. But I got it.
Not bad. But usually, I think even Indians don't read Mahabharata. That is the thing. So it's like an epic of. Maybe you heard it right? I mean, it's like the epic poem of fight between generational people fighting over who wants to be the king and all that shit. So it's a
The tale as old as time.
Yeah, exactly. It's one of those Homeric poem sort of thingy, and I think the tricky part of Mahabharata is that there is no one written source. It's always like, people keep adding some local flavors to it. So everybody who starts to tell the story, they're like changing and twisting and adding their own characters to it and then extending it. So, but anyway,
Yeah, and what's nice about it is that, unlike the Homeric epics or the sagas, that is one of the oldest epic poems which is still being told today.
yeah.
So there's still a continuity of like bardic tradition.
Yeah,
back
I
from
mean,
the days of
this is. I think it's because probably our religion is so much tied to these characters, and as long as the religion is there, it's all like it's kind of inevitable not to bump into this shit because everything is compared from that one, or every morality, a story is linked to that story, or Ramayana or Mahabharata, one of these things, and the whole the Bhagavad Gita, which is part of Mahabharata, at the not at the end but near the war, uh, the big war thing. So that's the central philosophical discussion in that one is still relevant. So you cannot, you know you cannot ignore Mahabharata. That's if you're an Indian. So anyway,
yeah, it's
I think
nice
that
that
concludes
it's
the Indian theology part of this podcast. I think we can get to the
Well, we had a bit less
meat of it
time,
now.
so
More coming, given there are billions of Indians. I think we will eventually, reach that conclusion that every programmer who is writing closure becomes Indian, by virtue of number of Indians.
Yeah, it's going to happen.
Yeah, it's
Let's
like
hope it.
there's a joke in Israel. After the 90s, we had a really large immigration wave from Russia.
Mhm.
So
Oh,
around after the fall of the Soviet Union, plenty of Jews who used to live there and couldn't leave just packed up sticks and came here. And
yeah.
around 10 years later, they started having a joke. They would ask people who were born in Israel, how long have you been living here? Don't you speak Russian?
Yeah.
So
I think
eventually, every programmer would have to be up to speed on their Indian myth.
Indian, yes, Indian myths and Indian food and everything.
Part of the curriculum.
Totally. Anyway, so let's talk about your coding journey. We'll get back to all the Indian mythological section of it again, I think.
Yeah.
So
These
how
are like
did you end up?
new sections of the podcast now. We've got Indian sort of stories and Emacs,
I
so
think
it's
so.
like,
Yeah.
I
mean, what else did you expect having an Indian Emacs guy on the podcast? I mean, after 80 episodes, it is going to conclude.
You're gradually
exactly. It's
bringing it
converging
in.
towards.
So I mean, you yourself are actually bringing this hegemony into reality.
The singularity is that writing Sanskrit in Emacs, and that is going to be the final singularity.
Programming in Sanskrit.
Yes, exactly. Let's not get there because there are a bunch of Indians who think that some years ago NASA decided Sanskrit is the best language for computing. This bullshit keeps on going on and on. So,
hey, it's just like arguing with common lispers.
Yeah, pretty much.
It has been standardized in the 80s. We don't need a new language. We don't need concurrency standards. We don't need functional data structures. There's
the web.
Yeah, there's a library for that. You can use FSET that has degraded the performance characteristics, and it's only logarithmic. We don't need your fancy newfangled data structures. Common Lisp is good enough for me.
Yeah. So why did you choose Clojure then?
So I didn't choose the Clojure lifestyle. The Clojure
Clojure
lifestyle chose me. I didn't start
You had
out
Clojure
as a computer.
thrust upon you.
Kind of, yeah. I was folded into the shape of a pretzel, and then my boss told me I need to rewind a bit. I didn't start out as a computer programmer. I started out as an electrical engineer, and
Like
so that
me.
real programmer,
an adjacent field, but
not,
I found myself in the
not this,
VLSI industry. Yeah, it's a pretty
not these
depressing industry.
peasants who don't study, electronics and have no idea how computers work. And
Yeah, so I
they're one
studied
of the elites.
electronics. I had to build a basic CPU in hardware
Yeah.
description language in school
Oh
and
yeah,
all that jazz. And
yeah.
I wanted to to work with electronics, and I thought it was really interesting. And I kind of sucked at it, and B, as a new grad in electrical engineering, I found myself sucked into something else, which was the VLSI industry in Israel, which sucks most of the uh, electrical engineering graduates who find themselves working either in Intel, Apple, or Amazon.
Yeah.
And I was trying to find myself there, and as I was still learning and developing, I started to have fun programming, and I was hacking and fighting with the internal tooling. And since I couldn't install anything because I had no sudo permissions on the machines we were working on, I had to compile everything. So in about a year, I found myself compiling GCC in order to build Common Lisp to learn how to program in Lisp. and and that combined with teaching myself some Python, I thought I wanted to do machine learning. That didn't turn out, but I was having lots of fun with Lisp and Scheme and SICP. And then, as I was training in Brazilian Jiu-Jitsu, I met my boss. And that's why I said I was being folded into the shape of a pretzel, because he kept kicking my ass.
And then thrown into a hammock.
Yeah,
You're the second guest who's been into Brazilian Jiu-Jitsu.
Yeah,
we
but
had
Will
Will
is way
Acton
more
on.
serious than me.
All right, okay.
He's a black belt, and I'm just a dabbler.
Oh, that's a shame, because I was
right.
just thinking, we should have an episode where you guys fight each other and then
Uh,
in jiu-jitsu.
I'm tapping out even before that episode begins. So anyway, I got to know Reshef, who's a great guy, and we would chat a bit about technology and stuff. And when I decided I wanted to finally make the change out of electrical engineering, I hit him up on LinkedIn and told him, "Hey, I heard you were looking for programmers." And he's like, "Yeah, sure, send me your CV." And then I checked on his LinkedIn, and he's the CTO of the company. He's the co-founder. Oh. So, okay, no pressure. The co-founder is your referrer. So I had to meet those expectations, and I came in pretty excited. Yeah, I think they're still laughing at me about how excited I was during the interview process. And then I started working in AppsFlyer, and I'm still there. And that's how I fell back into Clojure. And
nice.
I was, how fortunate is it to go from looking at William Beard lectures and my free time to not even having to cross the street to go to an interview, literally the next building over, and started working in Clojure.
That's super cool. I mean, like,
you literally could fall literally backwards into the work.
Exactly. So I both fell on my ass physically and metaphorically into that.
But before starting with Clojure, so you said you're doing some VLSI stuff. Is it Verilog or VHDL, or because those are kind of sort of functional stuff as well, right? I mean, they're not. I know they're because I've been there a little bit. I don't remember much of the shit, but I did some electronics engineering some time ago. I was doing pretty much the same stuff as well.
So I did the physical design part,
yeah,
and mostly related to timing simulations and analysis of data.
Yeah,
and even found some opportunities to utilize what I learned about homoiconicity and code generation in a
Yep.
few places because the hardware industry is still the only industry which uses Tickle, which is
Yep.
the only other homoiconic language
Yeah.
out there besides
Yeah.
Lisp.
But with Python bindings, or that's a TK and TCL, and
No, pure
build the
TCL.
pure TCL. Oh, okay.
Yeah.
Nice.
Yeah. So that was my life for about 3 years.
Yeah.
And then started with Clojure and all the practices and methodologies of software development and stuff like that. And I didn't really do VHDL too much, and
Hmm.
it's declarative, but calling it
Yeah.
functional or a programming language is a bit of a stretch.
Yeah. I mean, it's a
And
very specific domain-specific thing, anyway, right?
very,
But how did you? Because for me, it's a really big um, conceptual jump, right? Because it's like from Mariana Trench to Everest level. you're
of
you're
abstraction.
now. Yeah, exactly. Because when you're writing VHDL, you're like really at the guts of the thing, and then you're writing in terms of the signals and everything.
Yeah, but I
And
wasn't
then now
writing
you're all
VHDL.
the way up. Oh
Uh,
yeah, but
yeah,
if
I
you're
was
working at that
analyzing
level,
tons
yeah.
of data and writing workflows, and basically you can think of it as somewhere between scripting and programming.
Mhm.
And it also depends which part of the cake uh, you get to work on, because
Yeah.
chips, silicon chips, are such complex and conceptually big pieces of engineering that you can find yourself working on remotely different things and sitting next to someone who does something else. And
Yeah.
you're both
Yeah.
working even on the same piece of hardware, the same area
Mm.
in the chip. But you're writing code all day and he's running simulations all day.
Mm. Yeah. And how was the so because of Apps Flyer, did you start learning Clojure, or did you already start experimenting in Clojure? Because you said you experimented with Scheme and Common Lisp and all that stuff. So
Yeah, so I experimented mostly with Scheme,
Mhm.
and I got into Clojure, and looking at my foreclosure solutions from back then at the beginning, they look very schemish, and took me some time to learn the Clojure style and idioms. And I remember coming into Clojure, I thought, oh, that's barbaric. That's you don't need that. You don't need this. And I uh, came down from that tree in about a month when I
Mm.
realized it was actually useful and usable and readable.
Mm.
And
You mean things like maps and vectors and stuff like that?
yeah, and even having less pairs of parentheses in
Yeah.
Sure.
Yeah.
cont forms and let forms
Yeah.
and stuff like that. And since I didn't have any um, prior knowledge or background in software, I wanted to cover as much ground as I could, and to learn all the best practices, and to to find all the material I could about software engineering, because
Mhm.
Mm.
I felt like I needed to play catch up. And and having done that, I consumed a ton of material that it seems like people just skip, even in the software industry.
Yeah. Yeah. Yeah.
And and very quickly, I found myself becoming the person who answers questions, and not the person who wastes your time with questions. And and people would come to me for a 5 minute question and end up with a 1 hour answer.
So what kind of materials are you talking about?
Well, I didn't know anything, so it was about Clojure and about Git and unit tests
Right. Okay.
and type systems and the history of programming. And I ended up consuming all the Rich Hickey back catalog and Kevlin Henney and um, Joe Armstrong talks.
Mm.
And uh, I skipped all the introductory material and went right to the greats. And uh, Jerry Sussman and William Beard and Nada Amin.
Hmm.
So that was like my baseline an introduction to Clojure and programming, and those are that was what I was giving myself to think about and process as I was going through everything.
Yeah, but because the Common Lisp is well, quote unquote native, right? I mean, you don't have any VMs or anything there. I mean, except for the runtime, obviously. But Clojure has JVM, and Clojure script has JavaScript, and because we still feel sometimes like, okay, Clojure has this leaky Java thing coming in. I mean, not even leaky, because we embrace the host, like we using Clojure. So did you see, or did you catch up on Java related stuff as well?
Oh yeah,
JVM things?
I learned Java through Clojure because it was my
I
habit.
hope not Clojure code base. You mean through
That
Clojure,
too.
but not Clojure code base.
I and if you let me write Java now, I would write really weird Java.
Yeah.
Just like when I was fighting internal tooling and the back at work in Intel or Apple, I just went and read the source. So
Yeah,
all right, I was digging into Clojure and digging some more into Clojure, and then you reach the Java event horizon.
layer.
It's like, okay, what do you
Yeah,
do? You just go and read the implementation in Java. Well, obviously, no one told me it's weird Java, and
yeah,
so then I started learning Java and getting to know the VM and like, the fine details regarding that,
mm,
and
mm,
and I find it kind of it, it's not wrong, but and it's not coy, but there's something off about saying that, oh, Clojure has the JVM and it's leaky and Common Lisp is native, because in Common Lisp you can always compile against a native C library, and you don't say
yeah,
that leaks, right?
yeah.
You
No, I
just
mean, there
talk to
it
it.
is more. That's true, but there is more like correct me if I'm wrong, because I didn't have any commercial experience with Common Lisp, but the thing is that Common Lisp pretty much stands on its own, right? I mean, there is no, of course you can use foreign fund, FFI, and so you can use every programming language these days. You want to use C libraries. That's kind of a standard mechanism. But what I meant with Clojure is that Clojure basically it will not exist without having JVM. It's not possible. So
I think the other way of saying it is that, like, the Lisp runtime was made for Lisp, but the Clojure runtime was not made for Clojure.
yeah,
Well, that's true, and there is the Clojure and Clojure project, but it isn't like the official.
Never going to happen. I don't think
Clojure.
it's ever going to happen.
Yes, but it works. I mean, tools emitter works. You can use it to compile your own Clojure if you'd like, and you can write extra passes on top of that. No one is stopping you from using that as a compiler instead of Clojure eval. But if you want to do something useful today, you have to use
Common Lisp.
No, you have to use like a foreign library. You have to use the outside world. If you want to use Kafka and Common Lisp, you're going to use the C library, and if you want to use Kafka and Clojure, you're going to use the Java client. So I don't feel bad about having to target the JVM or having to consume libraries written in Java. And when you get right down to it, the JVM is a pretty good platform. And the fact that the compiler in Clojure emits JVM bytecode and not an executable, I don't care.
Yeah.
It works, and I have fun every day at work. So shut up, you back there in the crowd who has something nasty to say.
But what about the performance?
That is my my white whale.
So we finally reached the meat of the topic.
Ishmael here.
Yeah, I don't know how I got into that. I think it was by having continual slap fights with some architect who works with us, and I really hat off to that guy. He is very, very knowledgeable and professional, and he knows his shit. But guy probably married Java. That's okay. It's okay to each their own.
I hope he's listening to the podcast, and we can just say thank you for putting Ben through all this pain. So he's
Yeah,
working on the performance shit now.
I doubt that he is listening to this podcast, but I learned a lot even from his snide remarks and jibes and and things, because he each one of those would send me down a wild goose chase, and I'd learn something new.
Yeah.
That and
well,
watching.
hate is a form of education as well, you know.
Yeah.
Yeah, he's like the
or a motivation for education, let's say.
He's like the stern Zen master who
Right.
keeps hitting you or giving you weird tasks to do, and suddenly you find that you've reached enlightenment. So that, and he sent me to watch a lot of Gil Tenes
right.
Lectures about performance in the JVM, and even how to measure things correctly and what we're measuring and how we're testing it. And then naturally, what do? You start profiling and you start measuring, and you find a ton of performance lying on the floor just waiting to be picked up. I found lots of atrocious bad habits and performance mistakes. Everything from calling satisfies at runtime, and I found it inside our code base. I found it in open source code bases, like in the Lambda Forge data log parser, and that was the easy pickings where I started with. But as you get deeper into like async profiling and just-in-time compiling, and for the listeners who don't know, the JVM is a bytecode interpreter. It's a stack machine, but it's also it has a just-in-time compiler which can compile all of this down to assembly if the stars align correctly and the circumstances are favorable. And for some,
it depends on the phase of the moon.
Yeah, and for some pull requests, I even found myself analyzing JIT logs. In some cases, so it's a whole area of research, and you need to understand how those things interact with the hardware, not just the JVM, and how those things get first compiled to bytecode, how they run on the JVM execution model itself, and then how that maps to hardware, and that might behave differently in different JVM versions, and you need to make sure that the JVM is working as you'd expect it to work, and not that someone turned off your JIT to be helpful. And and then you ask a question on Ask Closure, and you say, hey, you know that you can go through this API instead of that API, and it will be way faster. And they say, well, yeah, theoretically, but why didn't you short circuit using count? And then you run up against the closure process, and you have to curb your enthusiasm a bit.
Before we go in a bit more detail, so why did you? I mean, given the fact that you're kind of like falling into closure, what made you focus on performance rather than aesthetics, or why were you suffering? Was performance why did performance become a focus for you? Because it doesn't seem like it's the most important thing in the closure world. I'm not saying performance is like, of course, performance is important, and in certain situations it's critical. But why are you motivated by that particular aspect of the language?
So it's one of those things where you also just find by accident. And I read about profiling and things like that, and I was just curious, and I said, okay, let's profile our services, because we process a ton of events every day, and maybe we could do it better. And specifically, we have an event-driven architecture in AppsFlyer, and tens of billions of events every day. So shaving even a few percent of performance there does mean real money
Right,
at
they
the
do,
end of
because
the
you're
month.
hosting on Amazon or something.
Yes, we're running on AWS and plenty of instances. And if you manage to save even a few pennies here, a few pennies there, the law of big numbers comes into play, and you can save a lot.
Yeah.
So, for example, when you cut out reflection from some critical piece of code, you increase your throughput by 25%.
Easily, more
Wow.
like 25 times, but
Yeah, so that wasn't even like the meat of the service.
yeah, right.
And by just cutting it out, it improved throughput by 25%. And that's real money when you're talking hundreds of instances.
Absolutely, and those are fairly simple savings as well, aren't they?
Pardon?
That's a fairly simple mechanism to get savings, just to avoid reflection.
Yeah, exactly. So that's one of what I mentioned about performance lying on the floor. It's you profile something, and then you see this big chunk of satisfies or merge or flattens, and you ask yourself, the fuck is that? Why is that here? Who did that? And it's a day of work to get rid of it, and suddenly you increased your throughput, or you increased your response time. And for example, if you have to serve billions of requests every day, increasing your response time is also something which might be critical.
Yeah.
So I was like infatuated with the beauty and the libraries and core, and I was getting into core async and core logic, and I was having tons of fun. And then I profiled some service, and I looked at the results, and I was like, guys, what's that? Why are we doing that? and and then suddenly everywhere you look, you see a ton of performance problems, or just things which accumulated just due to negligence and time.
So you have a T-shirt saying "I see slow code."
Sometimes. So now it's almost a joke at work that I'm the performance guy, and don't be careful if you come to me with questions about that. But
at what point you think you lose the because when you start writing closure, you don't consider these kind of things like putting type hints to avoid reflection or constants or whatever, all these things, right? Because those are ceremonial shit that don't contribute to the logic, or contribute to the thought process when you're writing code.
exactly, you
Like,
want to write beautiful code
because
eventually and have fun,
yeah,
not
exactly. And yeah, I mean, beautiful code that does nothing. That's the main goal. So nobody will call me in the middle of the night that your code is broken. It does nothing, so there is no bugs. But anyway, I remember a few years ago when I was working on a different closure project than I'm working on right now. It's like, okay, at some point we thought we went through similar kind of exercise, and then we started debating, okay, at this point it's better to write Java because it looks like Java anyway, because I keep
yeah.
throwing all the type signatures all the way, and then I don't use any of the dynamic stuff anymore. Like, what is the fucking point? Then I can just switch to Scala or Java. So where is the line for you? Where do you see that still keep the closure in Ness but squeeze the enough performance and the trade-off?
Yeah, so that's one of the important parts in measuring and profiling first, because
Yeah.
most performance isn't actually there. So besides
Mm.
avoiding reflection, which is
Yeah.
just a bad form in general,
Mhm.
most performance is lost on iteration
Mm.
and dispatching through kind of more dynamic or reflective APIs. And that can actually be avoided because if you know at compile time what you're iterating on, and you can actually know that plenty of times, so you don't need to detract from the readability or beauty or legibility of your code. You just you need something that will work with you at compile time, at some form, and let you work with that. And that's the just when I thought I was out, they pull me back in, and and Tommy's talk from Reclosure ended up with me writing CLJ Fast, which is, it started out as just a collection of heuristics. It's like, okay, I can take get in, and if I unroll get in to a series of gets, oh my god, it's 2, 3, 5 times faster. And as I was compiling these heuristics and working more on that, I realized that I was just doing something a compiler would be doing. Because what compilers do, constant elimination and partial application and
tree shaking,
tree shaking, and specifically loop unrolling and stuff like that. And it's like, and avoiding iteration is loop unrolling. And one of the problems is that iteration in Clojure, if it goes through first and rest, it isn't just slow, it also generates garbage. Because you call rest all the time on a vector, for example, and you keep allocating every time you do. So if you find a way to avoid that, you get faster code, quote unquote, for free. And that actually took me back to like the fun, useless shit, which is, okay, how do I write a compiler, or how do I write compiler passes to that? Because I don't want to just give someone a collection of heuristics. I want to give them something that they can apply wherever on things that the heuristics don't know yet or don't apply to yet. And how do you write like a general purpose Clojure inliner or a general purpose Clojure partial evaluator? And that gave me an excuse to get back into things like core logic and mini canron, and now the faraway goal is porting eval to canron. In like to core logic, and then I could maybe I could write like a partial evaluator for Clojure code.
Let's step back a little bit and unwrap a little bit, because can you talk about what CLJ Fast is and what is actually doing it? Okay, it says in the name, it's faster Clojure. That's understandable. But what?
But without writing Clojure that looks like Java.
Yes, exactly.
Like so that's the value proposition.
How does it do that?
It does it. The first rule of a macro club is to turn everything to a macro, and so you take the only tool that Clojure looked at and said, you know what, maybe we shouldn't, and you go all in.
Basically,
and because what do macros do? They let you jack in at compile time and just do whatever. So I just jack it at compile time and do whatever.
So my guess is that there is only one macro in CLJ Fast that says fast, and then I just need to wrap my entire namespace into fast, and then that's it. I'm done.
So it gives you drop-in replacements for the big offenders, let's say, which are get in, update in, assoc in, merge, select keys. These are the most pathological functions in terms of performance in core Clojure. And you can use them like you would the higher order functions, but you can't use them as higher order functions. You can use them at call site. You can't pass them as arguments. And if you make that compromise, you get back. You get all the performance improvements that they promise, which are 2 to 5 times speed ups depending on the function.
But does that mean they are only usable in? Does that mean they're only usable in my application code? Because usually when you're building Clojure code, well, not usually, I mean, that's kind of a standard thing that you keep pulling code from different libraries, right?
Yeah,
So
so you
they
can't
might still be
install them.
using underlying thing.
Yeah.
Yeah.
So one thing I want to try is to
Mhm.
add some way of installing them on Clojure core vars as inline
exactly.
meta. But
Yeah.
one of the problems is that if you can't inline, what do you do then?
Mhm.
You can't
Yeah.
call yourself, because then you'll get stuck in an infinite loop inside the macro expansion phase. So you
Yeah.
have to also provide an alternative. But yeah, you can do that, but I need to do that. That's like the
Yeah.
logical next step for the project. But I'm kind of afraid of exposing that, because
Yeah.
either you'll do that in your application and then you'll complain, oh my god, you broke my code, because there is some case the programmer, the library developer did not consider, and it was just used willy-nilly, and
Yeah.
I don't want that on my conscience. Or
Yeah.
or the one thing I'm even more afraid of is that a library that you require might install it,
Oh
Yes.
yeah.
Yeah.
and then
An
it's
older
like,
version of it. Yeah.
My
yeah,
code
or
is faster suddenly, which is pretty
yeah,
cool,
yes, but again, it might break your code, and you don't need
Yes.
that.
Yes.
So
Yeah.
that's something I need to consider, and like provide a ton of caveats and warnings, and maybe like have really fine-grained control over how those are installed. It's like you install
Mhm.
only specific uh, two specific functions,
Yeah.
not all
Yeah.
of them at once. But yes, that's the logical next step. I'm just chicken.
Mm. But
So
so
let's just
can
walk
you?
through this like get in. Why is get in slow? Because I think
Yeah.
that would be a good a
Exactly.
relatively straightforward, everyone knows get in. So, why
Yeah.
is that a slow?
So
Let's get in to get in.
Yeah,
So
let's go. Yes, very good.
it's slow due to two reasons. One of them, because it just iterates over a sequence of keys, right? So,
Mhm.
and if you know the content of the sequence at compile time, you don't need to do the iterations at runtime. You can expand that series of calls at compile time, right? You already know that. But there's another reason
Mhm.
specifically that get in is slower than it can be, and that's because it is defined before reduce is defined in Clojure. And since Clojure code is loaded sequentially, it has to use an internal implementation of reduce, which is slower but still correct, in order to even work,
Ah,
and which is called reduce one, which
Mm.
iterates over the sequence, not using the reduce API, but using first and rest, which, like I said previously, is even slower and generates garbage.
mm,
And you
Mhm.
find that people usually pass vectors as the arguments to get in. And
sure.
Mhm.
reducing over a vector via the reduce API, super fast, really good, way to go. Reduce one is slower on a vector than it is on a list.
Mm.
So sucks to be you, but yeah. A quick win patch for Clojure Core is to change get in to use reduce and not reduce one. That's a
So
really
yeah,
quick win.
they need to. It's defined after get in.
Yeah, or change that to get in one and to define get in later after reduce again.
Yeah. Yeah. Yeah.
Yeah.
And so that's one of the reasons which it's slow. Same for update in, same for soaks in. Places which take variadic arities, places which take a small number of variadic arities and then do iteration at runtime. For example, compose. If you
Mhm.
compose more than 3 functions, you don't just allocate, you reduce over the sequence of functions every time you call compose.
Right.
Mm.
So that's slow, that's kind of wasteful, and that also doesn't work well with a just-in-time compiler, because you could end up with like one function which is composed, and that will get optimized numerous times every time you pass through it.
Yeah, okay. So, I mean, you're really talking about these kind of functions that are sitting inside of tight loops or very heavy loops.
Yeah, but like, what's a tight loop? When you map over a sequence of 1 million elements, it becomes a tight loop, whether you want it or not.
Yeah, exactly. Yeah, yeah.
So,
it's not the sort of thing that you're worried about at the beginning of the program when you're doing configuration, reading, and that kind of stuff is what I mean, or when you know you're not going to be consuming large amounts of data. Or once you're in the core line of like, oh, I'm going to be streaming through, a log file or some other big stream of data, then you need to
or consuming from
optimize that
Kafka
part.
forever.
Right. Yeah.
At full speed, nonstop. Then that's where these things become relevant. And to fulfill my contractual obligations, I must emphasize these caveats. Don't just go optimizing and shaving nanoseconds off loading a config file. Do it on your hot loops and after you measure it, or Alex will chase me with a chainsaw or an axe or something. I don't want another talking to because because someone misread my advice with too much enthusiasm.
Right.
But then I think we should talk about a little bit about how you should decide to add CLJ fast to your project.clj. It's not
simple.
just I'm going to starting a new project, so just add this one and then everything will be faster for some reason.
You shouldn't.
Yeah. So what should be the
first rule of CLJ fast? Never
don't
use
it yet.
You shouldn't. There are two reasons you should even consider it, and one is looking at your Amazon bill at the end of the month, and saying, I can't afford this. And only if you're saying I can't afford this, then you should ask yourself, okay, where am I spending this money? Is it on compute?
If it's on programmers.
It's like, if I'm spending this money on compute and not on storage, not on S3, on instances.
Not on the traffic.
Exactly. If you're spending it on instances, then you should profile. Don't add CLJ fast yet. Go profile your code. And have results. Have actionable results.
That's look. I mean, that's a really nice point. And so, what kind of things that you recommend to profile your stuff? For specifically, keeping closure in your mind, because Java, there are plenty of tools out there people are using, and there is a bunch of tooling available which is mature enough. But if you're using Clojure, because Clojure produces a certain way of bytecode, and so what would be your recommendation?
Well, first, like, the Java tools are good, and if you're running on the JVM, take advantage of them. And you can even embed CLJ async profiler in your application, which I've done several times. And you can trigger it externally and just start profiling your application for a minute and get back like the best profile you can get, which is of a live application. But CLJ async profiler, Java flight recorder, Visual VM, use them. There's nothing about Clojure which says you can't use everything there is for the JVM, which is one of the best instrumented runtimes ever. Just use it. And find where your problems are before you just start treating everything like a nail with your happy hammer in hand. and after you profile, if you find that you're wasting like a ton of time inside Clojure core functions, and you want to keep your code idiomatic, and it's your application code, not some library or whatever, then maybe consider using CLJ fast, but not before. Like, there's a ton of things you can do before you reach for it. And it's actually more for, I'd say, library authors or stuff like that, and where they want to give themselves a more human-friendly API, but still have the best performance that they can.
Yeah, that's a nice pitch for your library, by the way. I mean, don't use it.
You don't need it. And
Yes.
the other case where you might need it is if you're not meeting any of your KPIs.
Yeah, yeah.
If you're specifically throughput or response time. If you're not
Mm.
meeting those, then again, go profile and figure out why.
Yeah. So thinking about because most of the functions, I'm assuming most of the functions because I haven't gone through the namespace of CLJ Fast. So they're mostly improving upon things that you have in Clojure Core, right?
Yeah.
The functions that we have. So what? Why do you think, or maybe let me put it this way? So when do you think Clojure Core should change to these versions of these functions?
Besides what I said about get in, which can use
Yeah,
reduce,
yeah.
only if better support for inlining is added.
Hmm.
Because currently inlining is only predicated on the arity.
Mm-hmm.
If inlining could be predicated on the arguments themselves,
Mm.
then it should be considered,
Okay.
but not otherwise.
So it's not something that you can just open at PR and, well, not PR obviously, send a patch to to the Clojure core. It's not a matter of, okay, let's improve this to a faster version. It's not just
You you
that
could
level.
you could,
Mm,
but you need to but you'll be adding inlining to
mm,
other expressions where there wasn't before either.
yeah, yeah.
And it's like it's a really big patch, and that's not where the problem is 90% of the
Mm,
time, not 99% of the time. The
yeah.
the problems are usually where people are using flatten or satisfies where
Mm,
they shouldn't. Not,
yeah.
oh my god, I'm churning get in like
Yeah,
you
a
know
million
what,
times.
and
Yeah, yeah.
and that's eating all my CPU. No, that's not there.
Mm, yeah,
But if you're writing a library, for example, and you want to say, oh my god, my library is so competitive, it's faster than everything else under the sun, so that's the place to inject some stories into your code or something, but not
yeah.
in general, I'd say.
Okay. And so,
But I think one of the things I saw in the get in was, for instance, you could use like thread first instead of get in.
Yeah,
And that seems like quite a easy win and still quite idiomatic.
correct. But are you going to do that uh, under the hood, or to just add that to Clojure? Because if you just add that to Clojure, you add this change for all users, and
Oh no, no,
suddenly,
no! I'm just saying as a
oh,
sort of heuristic, like you were talking about
oh yeah,
before.
exactly. And this is also why this was the first use case, because it, it's so apparent how you can do that and why it works, then that it's like the uh, case study to start with.
Mm.
But even one thing to consider, especially when you're starting to look at esoteric stuff like performance, if you add inlining and code expansion to Clojure, suddenly methods are going to have bigger bytecode.
mm,
Mm.
And not only can, in some cases, those things be optimized less well than before, although given Clojure's performance profile, it's usually not the case. Some methods won't compile anymore because you'll get a method body to large exception, which
okay.
you only see in core async sometimes when you write like a
Oh god.
huge go block. You might come across such a thing, but who knows? Maybe if you start mixing all of those, and someone had like a big function to start with, that function won't compile anymore,
Mm.
and you don't want that on your conscience.
Mm.
That is something I have never seen.
No.
at least
Yeah, so
at
I've
least
seen
in
it a
my
couple of
Clojure
times.
experience.
It's like take uh, a form which is like huge to begin with and try, for example, instrumenting it with Cider's debugger,
Yeah.
and you might get this exception.
Mm,
And it needs
okay.
to be a really big function.
Yeah, yeah.
So
Nice. So
surprises abound.
So basically, it's Emacs that usually produces these problems.
Emacs produces no problems, only solutions.
I don't think I need to ask the question, but anyway, for the sake of
If you require assistance, please dial MX, Emacs Doctor.
So Emacs or some other shit.
So I use Emacs for the same reason I fell into programming, because I had nothing better to use. It was either that or an edit. I was like, wow, I can download packages which enhance my user experience. My God, I'm using Emacs. I couldn't install an IDE or something fancy like that because no
Yeah.
pseudo permissions, and also no CPU cores. It's like I had 4 gigabytes to work with and like 1 core.
So there is a precedent for you getting into making things faster, giving you the slowest possible computer so you can make everything else faster.
or no, relative to Vim, Emacs was a bit slow.
Yeah.
But the user experience was an improvement.
Yes.
So when you grow up in darkness, you merely adopted the darkness. I was born into it.
Nice.
So
So
I was
obviously,
born in in adverse circumstances and had to make do.
nice. So this CLJ fast thing right now, is it something that you use in most of the critical infrastructure that you have, or wherever you find the performance things in at your work? Like how is it being used right now?
It's usually not, because that's again not where the problem is.
It's,
The-
it's usually people not paying enough money to AWS. That is the problem.
yeah, or you need to tear out some database and to replace it with
Yeah.
another, and it's a huge refactor, and that's where the effort should go, and not to
Hmm.
put in CLJ fast in this little place or that little place. But
Yeah.
I can think of a few use cases, but not plenty, and you could probably offload half of that to transformers in Mali and call it a day.
Hmm.
So you
yeah, 'cause
usually don't need CLJ fast.
that's because I like you say, a lot of it is down to other things, external things to closure, usually networking or databases or file systems or whatever.
Yeah, it's like,
Yeah.
oh, you're blocking.
Yeah.
Change your application
Yeah.
code to be non-blocking. Good luck. See you in 2 quarters. So that's how things usually go, right? And it's fun to run these experiments and to make a line go up and to get the biggest and most beautiful numbers. And okay, now I've done that, and in the industry, things and considerations are different, and emphasis
Hmm.
is on other things. But it's fun, and I learned a ton of things, and now I'm really good at finding the problem, but the problem is usually not in your get in.
Yeah.
So we're getting out of getting now.
Exactly. But that let me like get back into like the fun things, or like the beautiful things and the interesting things, because again, I didn't want it to be a heuristic process. So I went around reading about how you compile, like what's the general problem. The general problem is compilation. So I started reading about how you compile functional languages, and then I find myself reading papers about compiling Haskell, and it's actually very interesting. And the core Haskell compiler is pretty simple, and it's actually something that if you give me a month of quiet and intense concentration, I could probably port this to run on tools analyzer.
Mm.
And that would be interesting, and who knows what will come out of that. And like, there's no rule that says that you can't use, for example, a different compiler for Clojure, right? And
Mm.
uh, and the approach has always been, the core is small, the core makes sense, the core promises you stability, but if
Yeah.
you want something else, there's libraries for that, community libraries or contrib libraries or whatever. And no one did that yet, but who is to say you can't use a community compiler?
Yeah.
And and there has been attempts to make like forks of Clojure,
Sure.
but they were ambitious in that they wanted to build on top of Clojure and to change Clojure. And I'm saying, let's not change Clojure. I want your Clojure to stay written exactly the same. I want everything else to change around it.
Mm.
Mm-hmm.
But then I find myself running up against the wall of, I'm just not smart enough to understand those things, and type theory and
So you're
and
building a compiler tower. That's what your goal is at this point.
yeah. So that's what I'm building towards, but it's kind of rickety right now.
Yeah.
But I always find myself falling into some other rabbit hole to also, understand this problem better, because, like I mentioned previously, if I write some form of partial evaluator, like something else with evaluation semantics, maybe that will just let me like run what can be run, and that is inlining, essentially. Like,
Mm-hmm.
this is the part that you do know, this is the part where you don't know, and it it works great, and there are projects to do that, and it's like there's and there are like flashes in darkness of people who started things or proofs of concepts. There's Tim Baldridge made some initial port of Vow, if you're familiar with it, which implements F expressions in
Mhm.
Clojure, which are both macros and functions, but they
Oh,
run at runtime, and I want to do the opposite. I want something that will run only at compile time. And then there's, again, the eval implemented in Canron or something similar.
yeah.
So that's how uh, I keep myself entertained by looking back into into the beautiful useless stuff, which is like very complicated, and I wish I both had more time and, I don't know, more brain power, more capabilities and capacities to even deal with that and understand it.
But the idea that you're floating, or you mentioned that you know closure language and then closure compiler, like different types of compilers for the same thing, which is something Haskell did as well, right? There is a Haskell specification. You have GHC, which is a kind of canonical Haskell compiler, and you have several other Haskell compilers as well available. C, another example. There is several different compilers. Mm, this is not really that far fetched, right? Because Michiel built Psi, which is kind of, well, not a compiler, but is a small closure interpreter, which is a kind of a subset of the thing. So it is similar to that, right? It's not really that blasphemic to say that, okay, we're going to create a different compiler for closure. Maybe not a fork, maybe a complete rethinking of how the compiler should be built with different principles. Because the closure has been built like 10 years ago or 15 years ago. Then there is a different techniques available, different JVM is changing as well. So there might be other things that we could add without breaking the existing one. So if you want stability, you stick with that one, and then while this new experiment continues. So this is
Exactly.
not that far fetched, is it? Right?
Yeah, and there's just like there's room for new ideas, and
Yeah.
basically the Clojure compiler has no compilation passes,
Mm.
and it's one of the promises in Clojure, right? It's
Yeah.
simple and dynamic, and you
Mm.
need that, especially for development time. But
Mm-hmm.
if
Yeah.
you're building a, a single artifact in the end, which is an application which runs somewhere. Maybe you don't need that.
Yeah.
And there's room for those considerations.
Yeah. Because I think it's something similar to, maybe conceptually similar to, there used to be different JVMs as well. Well, still there is, I think there are, because JRocket was supposed to be super fast JVM compared to other ones, and their Borland people were innovating by changing the JVM or runtime, Java runtime, sorry, even faster, different ways of doing this. So you could write Java, compile it, and then commercially, when you're running it on production or something, you switch to JRocket to squeeze every bit of performance.
And
And
this isn't the
for
only, and this is happening today too. The
yeah,
the Graal VM
exactly,
JVM
Yes.
is a new
yeah,
JVM which is developed
yeah,
by Oracle, and
yeah,
it has like a different compiler, and this compiler should
yep,
allegedly give you better performance for languages like Clojure and Scala
yeah.
because it handles the dynamic code better.
Mm.
I think Mikhail Borkend has actually proven that Psi runs faster
Yeah,
than
yeah,
Clojure.
There's
Not for all cases, obviously. I'm not trying to
yeah,
say that,
and this is like ahead of time compilation. But even if you use the just-in-time compiler at runtime, you do get better performance, especially for languages like Scala and Clojure, because it's new and it does new things which you can't necessarily backport to the old just-in-time compiler. Just has a
yeah,
different approach,
yeah,
and with different approach come different results.
yeah. So is this something that you have on your radar, like you're thinking, because you're going deep into how code is built and how it is being compiled, and you're I might even say you're going back to your lower level of abstractions that you're used to where you started. So is this something that you think is a reasonable goal for community to rally around, and then it does it give enough return on investment doing this? Because as you said, we're not changing the language at all, because language is the language, that's it. It's more of the how do you compile the thing changes.
Yeah, it, it's possible. Like
Mm.
I wrote, even managed to write about half of the beta reduction pass on
No?
Tools Analyzer. So it's
Mm.
completely possible and doable, right? The
Mm.
the question is, should we? Like, yeah, I know it's possible, but is
Yeah,
this
yeah,
what the community needs to rally behind right now and to invest resources in and stuff? I don't think so.
yeah,
It's
yeah.
cool. It can be a nice pet project and something to keep on the back burner and perhaps as a proof of
Mm.
concept and as a beginning of an implementation and to see if it's possible, and if
Mm.
it is, great. And if someone really needs it, then they will invest time in it. But I don't see a burning need for that yet.
Yeah,
Like that,
yeah, yeah,
there are both like other problems and other stories.
Well,
yeah.
my guess is that these kind of things, and again, it's just my guess is that these things are rarely useless, and you might find that, for example, you could come up with some tooling on the basis of these things that could help developers. Not necessarily something at runtime or actually compile time that really affects running code as such, but I can easily imagine having those kind of additional bits of data that you could inject via that extra compilation phase being something useful at development time, actually.
Even before that, one of the most interesting problems here is type inference. And the
Right.
CLJ Condo, for example, does a partial type inference, and you can even connect this with tools like Mali. But
Mm.
imagine if you could, because now, for example, Clojure, CLJ Condo doesn't keep track of the types associated with values like with keys inside a map. It knows that something which returns is an associative collection, but it doesn't keep track of the type for each value. But you could. So
Yes,
you
yeah.
could. So even without writing a compilation pass, even just a type inference pass could be incredibly useful. And this
Great,
is something which is worth investment in. But
yeah, definitely.
but it needs like a ton of theory on top of it. That it's not trivial at all.
No. But it just seems to me that a lot of these things where you kind of invest time and effort into understanding these phases of compilation of how the language is actually generated, these kind of things will eventually pay you back. And like you say, you might find some bit of infrastructure that suddenly could help plug into linting tools or other kind of performance tools or code formatting, not formatting, but code management tools. Detecting that this bit of code over here is the same as that bit of code over there, and why have you got it in two places? These kind of things,
Yeah, although there are arguments why you actually would want to duplicate code
Sure.
in some circumstances, but the one of the coolest projects I have seen recently is someone wrote Hindley Milner type inferencer on top of Mali.
Oh,
Yeah, and
gotta look that up.
I saw that and it blew my mind, because if there's like anything or any work to throw weight behind and like involvement behind and things which could pay dividends not in a month but in a year, it's that, I'd say. That is something which, for my money, and this got me excited. It's one of those things.
Yeah. So what you're saying is that, because there is a long dream, isn't there, that maybe is putting, I mean, obviously spec is a kind of type of types on top of the language, but you're saying you can do it through inference as well, and then you can actually inject real types.
Yeah, but even with predicative types, you can do it. I mean,
Sure.
okay, you have a spec, but how do you propagate the data about your spec throughout your code, right? Because you have some type associated with a key, but how do you know 3 functions down the line that
Right.
this? Because when you access that key, how do you know that you're going to get that type? So
Yeah.
you can do it with a spec just as well as you can do it with another system. But propagating this type and you and now you go back to logical programming and like unifying all this data and across the code base, and also finding where this unification failed and reporting it, is like the hard and very interesting and very useful challenge. And we're probably moving in that direction, and in the direction of like more tools and things which run on top of the code. And like
Right.
because if we generalize like the idea of, okay, a compilation pass is just some pass that runs over our code, but everything is a pass that runs over our code, like type inference and linting and compilation itself. We're just passing over our code and we're doing something to it. And how much can we do with that idea, and how far can we take it? And also, if you watched Jerry Sussman's talk from the reclosure, where he talks about the idea of just overlaying more data on your code, and just another layer of data and another layer of data, and those things can perhaps come into play at runtime or just at compile time or both, and like where the code represents more than one thing uh, at a single instant, right? But it's like an architect's plan where you have like different layers.
Different views, different elevations.
Yeah.
So maybe we can start treating our code like that, or build tooling for the code which do that. And spec kind of does that, right? It's a layer of annotation which you can activate at runtime, and you can activate it at compile time, or like at spec time. You add another time. You add another time slice for your the development work cycles.
Yeah, I mean, like you said, that I mean, this is one of these fundamentally annoying problems, is because it's kind of like we're waiting on spec 2, where we're kind of like the tool building exercise hasn't really started in earnest yet. So I think there's a lot of incipient work or a lot of putative work that could definitely be released on the back of that kind of the solid foundation.
Yeah, but there's also other tooling which we can build, and that's like radically different tooling. And one of the weird ideas I've been playing with, and the blog post I need to finish, and it's at who knows how many words by now. One of the things, for example, which annoy me to no end with Git is that, well, Git is a graph and it's nice and good. It saves diffs, and oh great, it saves diffs. It's immutable. It's functional. It's beautiful. But those diffs are in lines of text. But but if you treat your code as a graph or as a database, then you can talk about changes in your code as changes in the database. And we already have a plethora of databases for storing graph-like data and treating them as like immutable things. And we even have today a language for saving the diffs, which is what's the name of this project? Diff script, I think.
Oh.
Which reifies diffs in closure data as a sequence of instructions. So fuck it, let's throw all the code into into Datomic, and our version control will just be the log, because that's
isn't it
all you
something
need.
that
Sounds good.
Richiki mentioned with the codecs, right? I mean, with the
Pardon?
codec project. Yeah, when Datomic was announced, I think Richiki was building this storing code as codecs, like smaller structural things inside Datomic. So storing, it's basically replacing the whole.
Yeah, the idea is that you make
ions, right?
it based on no. Codec is this like
codec.
Didn't really happen kind of like project.
It was just like
And it was based around this idea of using functions or vars as the basic model for structuring everything, and not lines of text or even repos. In fact, to use the information about the whole project, which is where I think that I'm interested in that kind of space as well.
Yeah, and maybe one day we'll make it to the 80s, to where Doug, okay?
Yeah.
Everything okay there? All right. Maybe one day we'll make it to the 80s, where Smalltalk was, and we'll finally have an image-based closure, where the code is saved in a database and everything is just data.
Yeah. Well, I'd love that idea.
Yeah, but there are like a ton of barriers for making it happen. Even how do you share that?
Yeah.
How do you collaborate?
Well, I mean, if you worked in the 90s with Visual Source Save, that's how you used to share it. You just share it, and then you don't check in, and nobody can check out, and you're fine. Or you just share it like on SharePoint. You just copy the folder somewhere, and then.
No, I think you can have. I mean, my view of this is quite straightforward, Ben. Is you can have an image and you can share the image, but there's no problem, because if two people have the same runtime installed, you can do that. That's fine. Just like merging databases, if you like, or having distributed databases. That's definitely solvable. The biggest problem is if people don't want to, if people want to use Emacs rather than your image editor, then you
That's
have
not a
to
problem.
have an externalized, you have to have a serialization format. And that's
Yeah.
just Git, isn't it? That's the standard like file-based serialization format that is
Yeah.
Clojure now. So we've already got like Eden as a serialization format. So it's relatively straightforward. The problem though is you'd lose some of the metadata and some of the image information. Lose might be a funny word, but that's you can store that somewhere else or emit that somewhere else as a sort of configuration data. So I
No,
don't think it's insoluble.
theoretically, you could emit all of it, like both in
Absolutely,
text
yeah,
files and even because then you can run like the diffs on the text files and generate the Git diffs yourself. So someone could theoretically just download uh, you could expose it as Git, right?
exactly, yeah.
But that is like still dead code or stateless code. But imagine, if you will, because for that you won't only need the database, you would also need an editor. So you have a VM, you have an editor, you have a database which replaces your file system. So you have an operating system.
Yeah.
No, you just
And
have a database with an editor. That's kind of normal. I mean, most of these
that's
editors,
kind of
like these
Emacs, huh?
no, these IDEs basically have databases with databases at the back end for indexing and that kind of stuff. That's how
Yeah, but
they do all this kind of like static
yes,
static
you're running on a
analysis,
VM
etc.
too. So the VM is like,
Mm-hmm.
you have a user interface in terms of the editor, you have the database instead of a file system, and it's epochal, so it's purely functional, and you
Mm-hmm.
have the VM which replaces your operating system. And then all you need is a global namespace, and then you could have, because if, for example, like you had a global DNS for everyone, like even if you refer to it through GitHub reverse DNS, so
Sure,
you'd be able
yeah,
to
peer-to-peer networking, yeah.
so I could like directly clone this code, or even just read the code, because we're all talking the same language, like the language of the database. So if we're all talking the same language, I could just query your database for this.
Absolutely, why not? Yeah.
Yeah. So that's like the farthest you can take this idea.
But isn't this something similar to, maybe I haven't gotten into it fully yet, but isn't this something that Runar and what's the other guy, Paul Chisano from Scala community building, like the Unison language? Because
Yeah, a
that
bit like that,
seems to
yeah.
be having the similar kind of ideas around it, right? Like,
Content-based,
yeah,
addressing for functions, yeah.
yeah, exactly.
Yes, but that's only for your code structure. What you talked about, recognizing, for example, that two pieces of code are the same, so you're just storing them the same. But that's like
Yeah,
an optimization.
yeah,
But
yeah.
this is like a very this closes like the gap between the personal development and personal computing on this
Mm,
platform and collaboration.
mm.
And
Yes.
it's like what you're lacking here is like a way, not just a protocol for communication. And by the way, we can all just transmit Eden to one another like
Yeah, yeah, yeah.
civilized individuals. So
Yeah.
we all communicate data back and forth, and we all exist in one unified namespace, which we can just use DNS for. And then you can even think about it as one distributed database where
Mm,
all
Yeah,
the data
absolutely.
is namespaced, right?
yeah.
So you create and technically, right? If you really wanted to get technical, that's also a blockchain. But instead of
Hey, no,
but instead of
besides blockchain. Yeah,
it's people focused and not like money
yeah,
or trade or whatever focused, like, because it
Mhm.
is,
yeah, yeah.
it's still like cryptographically verified, because
Mm.
that's how you communicate via HTTPS, and
Yeah, yeah.
it's all kept track of, because all the communication will probably be written to your database. But
Mm.
Yeah, and you can have a
Well,
Merkle tree for the Git equivalence, to
exactly,
reduce your diffs, etc.
but the thing that stands at the center of this system is the individual user, and not like some distributed transaction log.
Yeah.
Yeah.
So this is like an emergent property or an emergent structure you can find in this, but it functions very, very differently than, let's say, existing blockchains, because it doesn't care about trade at all. Trade isn't even a function here.
Yeah.
It's just the way it
It's just
happens to
a
work.
sharing and globally distributed database. That's it. That's all it is. Yeah.
Exactly.
Well, the main reason why blockchains have these characteristics of trading, etc., is just because they want to use tokens to let's say allocate resources in a fair way. Because if you've got a distributed environment, you need some mechanism to make sure there's fair play in that environment. So you have to think about that. I'm not saying that the blockchain is the answer or cryptocurrency is the answer, but there is a reason why they exist.
Yeah, I'm not saying that you
But
don't need them. You need
what do you mean?
some
Like
form
making sure that people getting rewarded for participating in it, or
Well,
something
let's
like that.
say everything costs money to like host or to to manage. At some point, if you've got a globally distributed environment, someone's got to host that thing, and so costs have to be paid.
Or even look at it backwards. You want to make sure you need to throttle the process in some way, because, for example, you don't want someone to DDoS you, right? We all
but
exist
this
now
is
in a global
something.
database.
If you remove the so-called financial aspect of it, I mean, that's basically CPAN, that's basically PyP, that's basically NPM, and Maven, and nobody's
but
paying a
NPM
single
and
penny for
Maven
those
have
things.
financial aspects.
Where?
Well, someone's paying for those storage.
Yeah, totally. That's what I'm saying. Like there is
you can't remove the financial aspects.
No.
I mean, say
it's
remove
not,
them.
No. What I meant is that 99% of the people who are using it, participating it, pushing to it, are not getting rewarded or not thinking about.
Yeah.
That's what I mean. Like, so if there is enough minds or enough people who can host this, who can build and then support this, because there is no frenzy of I'm gonna mine and then get the shit and get rich quick sort of shit is eliminated. Then none, like since the days of CPAN, which is like back in the day, like 20-30 years ago, since Perl started, we do have that distributed, even source forge, like and
but
multiple mirrors of Apache software. So
they're not distributed.
No.
That's the problem. They're all
No.
central archives.
I totally agree, but there is a precedent for removing the financial thing, and still it's totally, it's good for the programming community on the whole, right? That's the reason why it is being supported, and there are companies behind it, but either doing
but they're not
altruistically
removing
or
the financial thing, no, VJ. It's just
no.
being
But
hidden underneath some centralized funding mechanism.
Of course. So if we use that one, but change the technological component can be changed to what we're discussing now.
Sure, I totally agree with that.
And let me throw another wrench in this, because you're still relying on something which is centralized for this to work, which is DNS.
Yes. Yeah.
And it's like, if you really want to buy addresses, and it's like you're not buying it from a reseller, there's like 6 organizations in the world which you can buy it from, and if they decide you're not buying one, you're not buying one.
Yeah. I mean, DNS is a mafia anyway.
Yeah.
Well, I mean,
it's a cartel.
there are blockchain-based DNSs, so
Yeah, and you can all add me on GNU.net and.
Well, I mean, I think we shouldn't mock these things. People are doing, the open source world and the Linux world, they are doing lots of interesting work.
My heart goes out to
systems, peer-to-peer, IoT stuff. There's a whole bunch of these things. So, there is some potential for that kind of stuff. But I think the main point I'm trying to make anyway is that in order to get it to be distributed, even if you have to have some like centralized addressing, which wouldn't be too bad, but then you still have to have this concept of community. Now, whether you do that community in terms of like everyone just basically having a kind of social contract, let's say, where there's enough people hosting or providing compute that we don't need to pay for it, which would be, that would be the perfect situation.
Yeah.
But it's rare for humans to collaborate at such a scale, that we might dream of. Although there's only like 4,000 Clojure programmers who would ever do it, so maybe you could put it in the terms and conditions.
It's only 1,000 programmers who are Googling for Clojure. There are plenty of people who are experts at Clojure who are not Googling for shit.
First, get them to agree on a dependency inversion framework, because we are at about 4 right now. Let's see, we have component, and then it wasn't fun enough, so we have mount, and then we had integrant, and then we have clip. And are there more? I accidentally made one. I made one by accident which was specifically for like streaming data flow applications. So I made one by accident too. But yeah, so we have 4.5 going once, going twice.
Anyway, look, we're go on. Yes, yeah,
we have other social problems to solve.
Yeah, we're going to run out of time here. This is like,
but there's been quite a journey, starting from Indian mythology and ending up in blockchain. So I think
there's probably a rule about that, isn't it? That everything. Maybe this is going to be the future episodes. It's like Indian mythology, blockchain, and Emacs. All these 3 things have to be combined.
We should have our own. What's that? Every online discussion results in Nazis.
I am
like every podcast episode.
And now we can tie it back with I am become blockchain, the destroyer of the environment.
That's exactly what is written in Bhagavad Gita. So,
Yes, that's the only part I read.
I'm the creator.
Yeah. But
so everything is just me. So, you're just witnessing this shit. So
yeah, so don't feel sad. So
exactly.
Don't feel distressed because you have to go to war and kill a bunch of people who happen to be your cousins.
No.
Don't feel bad about that.
Yeah. Uncles, aunts, everybody. So just eliminate the entire family tree. Nothing is on you. No.
Exactly. So don't feel bad about mining cryptocurrencies on your aunt's computer. She doesn't need that CPU anyway.
Exactly. Anyway,
crime and punishment all over again here.
On that great piece of financial advice, I think we should reach to some sort of a conclusion. And you can find all the awesome stuff that Ben is working on his GitHub. We'll link that one. And the only thing, if you zoned out on this 1.5 hour episode, the only thing that you need to remember is that go and replace every core function with CLJ fast function. That's what Ben said.
Please, exactly. That's exactly what I said. Just I think maybe you skipped one word there.
Yeah, maybe I'm paraphrasing a little bit.
Urgently, I think was the word.
Yeah. Immediately.
Do it fast.
Yeah. Do it now.
Exactly. Hey, it's been a pleasure, Ben, talking to you, and apologize for the delay in showing up.
Shit happens.
But it's been super fun. I'd love to see all the ideas that you're putting into CLJ Fast being picked up. The whole compiler idea is super interesting to me, as well, as we discussed. Hopefully, I think we'll see more and more of it, and we end up paying less to Bezos. So I hope so.
I think we can all applaud that one at the end. Yeah, that's good.
So you're doing God's work. trying to reduce his net worth, a small dent in his net worth by making Clojure faster. That is running on AWS.
I try when possible.
Yeah.
Thank you,
cool.
guys.
That's it from us, and we'll be back soon with more for DEFN. Stay tuned. Bye.
Bye. Thank you, guys. Good night.
Thank you for listening to this episode of DEFN. And the awesome vegetarian music or the track is Melon Hamburger by Pizzeri. And the show's audio is mixed by Wouter Dullert. I'm pretty sure I butchered his name. Maybe you should insert your own name here, Dullert.
Wouter.
If you'd like to support us, please do check out our Patreon page, and you can show your appreciation to all the hard work or the lack of hard work that we're doing. And you can also catch up with either Ray with me for some unexplainable reason. You want to interact with us, then do check us out on Slack, Clojurian Slack or Clojureverse, or on Zulip, or just at us at Defen Podcast on Twitter. Enjoy your day and see you in the next episode.